Hey guys, Mr. Milton here. Today we're looking at volume of pyramids and cones notes. In this video, you should be able to find the volume of a pyramid and a cone. Okay? With pyramids and cones, we needed to find the slant height to find the surface area. With volume, we need to find the altitude, which is the perpendicular segment from the vertex to the base. Most times this goes through the middle of the pyramid or cone. Okay, I've put a video in the enrichment or extra column on Canvas. Check that out. I think it'll be helpful in understanding this next part. All right, the video starts with a pyramid and a prism with the same base and height. It then shows that it takes 3 pyramids to fill, or 3 pyramids of water to fill the prism. Therefore, the volume of a pyramid is 1/3 of the volume of a prism. Okay, and remember that we found the volume of a prism by doing the area of the base times height. So if the volume of a pyramid is 1/3 of that, then we can come up with our new formula of volume is 1/3 area of the base times height. Okay, important here that when we talk about height, you'll notice that we did not use L, right? We're talking about the altitude from the vertex to the base. Okay. All right, so first example here, we are given a square pyramid. Okay, we need to find, and we're also given the height, 9 centimeters. Okay, so we need to find the area of the base, which is 8 times 8, 64. And so we have to do volume equals 1/3 area of the base times height. So multiply this through, that gives us 192 centimeters cubed. Okay, again, we're working with volume, so make sure you're using cubes as your unit or cubic units. All right, number 2. Again, they gave us this perpendicular height, so we have our altitude of 17. The volume is 1/3 the area of the base times height. Okay, so the area of the base in this case is a triangle, so we will be able to find that 1/2 base times height, 8 times 14. Okay, and that gives us 56. So we find that the base of this pyramid is 56. The height is 17. So multiply 56 and 17, that gives us 952. So the volume is 1/3 of that. And so we can write that 2 different ways. We can either write it as 952 over 3 units cubed, or we could write it as 317.3 units cubed. Look at our next example. It says, imagine that we have a prism with an identical base as the pyramid in number 1. What would the height of the prism have to be so that the prism is or has an equal volume with the pyramid? Okay, so as we're looking at it, it says identical base. So if it's a cone, or sorry, a prism, identical base. Okay, we would have 8, 8, right? We don't know what the height would be. So our volume would be area of the base times height. Oops. So square base, 64. Don't know the height. In number 1, our volume was 192. And so we can plug that in and say, basically 64x equals 192. Divide by 64. and we find out that our unknown height would be 3 units, or 3 centimeters, because number 1 was in centimeters. Okay, and so again, showing that relationship between pyramids and prisms, because a prism is, or a pyramid is 1/3 of a prism, then the height needs to be 1/3 to make it equal in this case. Okay. Let's talk about cones. Okay, cones are almost exactly the same as pyramids, except instead of the base being a polygon, it is a circle. Very similar to what we talked about with cylinders. Okay, therefore, the formula for finding the volume of a cone is volume equals 1/3 pi r squared times height. Okay, again, we use pi r squared because our base is always a circle, so it's always pi r squared. We could write 1/3 big B times h means the same thing, okay, because our base is a circle all the time. All right, so here it asks us to find the volume of each cone in terms of pi. So as we look at our first problem, we have our volume equals 1/3 pi r squared times height. Okay, so plugging in all we know. Pi, our r value in this case is 10. Okay, I know it's written differently. Maybe you'd like to see it this way, but it doesn't matter. It's a radius, okay, from the center to the side in a circle. So, and our height is 16. Okay, even though this height's drawn to the outside, it's still the perpendicular distance from the vertex to the plane that contains the base. So multiplying this through, we get 100 times 16 times 1/3 pi. And so that's 1/3 pi times 1600. Okay, and so then we find that our volume is 1,600 pi over 3 centimeters cubed. Number 2. Here they give us this measurement 7. We're asking to find the volume, and so volume is 1/3 pi r squared times height. Okay, but we got to remember that our height is in the altitude. It is not the slant height, which they give us. So the 7 is the slant height. But we have a right triangle, so we can use Pythagorean's theorem to find out what our height is. And so, knowing that our radiuses are already 3, we need to find our height. So we can use 3 squared plus h squared equals 7 squared. So 9 plus h squared equals 49. H squared then will equal 40. And we have to do our tree, or we can do our tree. And we get that it is 2 radical 10. Our height is 2 radical 10. Okay, so now with all that information, we are able to find the volume of this figure. Volume equals 1/3 pi times r squared times height. We found to be 2 radical 10. Okay, so it's at 3 pi times 2 radical 10, so 610 radical pi. 6 radical 10 pi. Did I say that right way first time? All right, meters cubed. Okay, let's look at some relationship stuff again, just a little bit. See how our measurements change when our measurements change. It says, what is the volume of the cone? In this situation, it says the cone's base has a radius of 4 feet and a height of 6 feet. Okay, so if our radius is 4 and our height is 6, we have 1/3 4 squared pi times 6 So 16 times 6 is 96. 1/3, 96 pi. And that gives us 32 pi feet cubed. What is the volume if the radius is doubled? Okay, so if our radius is doubled, 8. Height stays the same, 6. Okay, so we have 1/3, 8 squared times 6. 1/3 pi. Okay, and so that gives us what? 64 times 2 pi, which is 128 pi feet cubed. Okay, what is the volume if the height is double? Okay, so from our original, what if our radius stayed the same at 4 and our height is double? So we got 1/3 pi 4 squared times 12. So 16 times 12 divided by 3 gives us 64 pi feet cubed. And then what is the volume if the radius is cut in half? Radius is 2, height is 6 from our original. So we'd have 1/3 pi times 2 squared times 6. So 424 divided by times 3 is 8 pi. Okay. Notice how these are changing. Our radius, when our radius changes, it has a larger effect on the volume of our cone, which makes sense because our radius in our formula is squared. Our height is linear, right? It's to the first power. So just notice that relationship. Okay, try this out. It says predict the volume if the height is cut in half. Try that out. Okay, hopefully you saw that that was 16 pi feet cubed. Okay, and that is volume of pyramids and cones. See ya.